So today we are going to discuss the probably the last part of ER diagram or maybe conceptual data modeling. Right? Probably the last lecture we have discussed how to convert or how to map a logical conceptual schema into the logical schema. That's what the last thing we have discussed. Uh, as a part of conceptual data model, we have discussed that how to model each and everything given in the data requirement and how to map these data requirements into the form of ER diagram, basic ER diagram modeling, right? So that's what we have discussed till now. And after that, we have taken the concept how to map the ER diagram, this conceptual data model into the logical data model, because it is a logical data model which needs to be created. Whenever we are designing a database, it is the logical data model which you are going to eventually create or eventually implement, right? Along with the basic ER diagram, there is a need of some additional features or maybe advanced features onto the ER diagram itself, right? So the basic ER diagram we have seen there, we have listed attributes of entity, relationship between entities, and different cardinality constraints like total participation, partial participation, and this min-max constraint, right? So that's what we have discussed as a part of basic or the fundamental ER diagram. Right. So today we are going to discuss extended or maybe the enhanced ER. There are two properties which we will be discussing. So the first thing, let's see why these two properties are required. Right. So let's take 2 minutes to discuss the possible situation or scenario for which we need to have this, enhanced ER diagram. So the first condition could be like in any ER diagram, if you observe there is an entity, and entity could be having list of attributes naturally, and if you observe that uh, in the entity, within the entity, in the future when we will have values or tuples in the entity, there is a need of simplification. There is a need of splitting the entity for the simplifying the entity, something like that. So like in the case of company database, when we have taken uh, you know employee as entity. So if you see into the employee as entity, you can easily identify that in an organization where we have 10,000 or maybe lakhs of employee. In that case, not each and every employee is having similar kind of designation, similar kind of jobs, similar kind of attributes related to their detailings, right? So it is better to split the relation. It is better to split the employee entity itself, right? For better purpose, better management of the entity and its data, right? So it is because primarily we are having few attributes applicable to some set of employee. For remaining set of employee, there are different attributes applicable, right? Like in the case of a student also. So if you capture all the details about a student into the student entity, uh, yes, naturally for BTech students, the courses they enrolled is important. The project they done or internship they do, it is applicable. But research publications and thesis titles, all these things will not be applicable. These things will be applicable for MTech and PhD students. So similarly, when we say any entity on a ER diagram, sometimes for few entities, it is possible to simplify them, right? Simplify them because for that entity, there could be few tuples where the values are not applicable for some attributes, right? So there you need to place what? Null values. So that's why we are trying to simplify that entity, right? So this employee entity will be further splitted, further decomposed into more than one entity. These entities are referred as a subclass or maybe sub entities, and the purpose is to simplify the or to reduce the null value possibilities, and to do, so very basically clarify or provide more detailed explanation on the entities attributes for some type of object, right? So this is the first step, or this is the first practice which needs to be done whenever we are we are making or we are preparing a conceptual data model in a improved form, or maybe you can say we are trying to enhance the understanding, something like that, right? So the very first thing we will discuss today is the concept of specialization. So specialization will be performed or will be required on the situation where we are trying to simplify our database entity in a year diagram, right? So we are simplifying a entity at a time in a year diagram. That's what the theory is. Now there could be another possibility. The second possibility could be like, suppose due to some government policy changes, two banks are merging. So like in the few years back, government has proposed that now Punjab National Bank and Axis Bank needs to be merged, something like that. Punjab National Bank and I think OBC Bank needs to be merged into one single bank. So whenever we see these kind of situation where two similar kind of uh, databases or two similar kind of situations needs to be merged. So on that situation, what, because two banks, merger of two banks will see the similar kind of entity in both situation, and in the entities we will see the similar kind of attributes also. So whenever we see this kind of situation, we used to perform generalization. So generalization is to merge, is to combine the entities, right? So whenever we have two types of two equivalent or two similar entities, we can perform a merger, we can perform a combination, right? And naturally, to perform a specialization to generalization, there is a specific step, there is specific approach given. So the purpose of these two features is to enhance the basic ER diagram. That's why it is called enhance ERD. It is double ERD. Now, to perform this, naturally we have these two features, specialization and generalization on the ER diagram, naturally. So we will be given a basic ER diagram, and then when you realize that, okay, there are some changes, there are some simplification needs to be done on this basic ER diagram, then you have to go for specialization or maybe for the generalization, right? And it is observed that theoretically, whenever we add these specialization and generalization, the database schema becomes more accurate. It conveys more detailed properties or maybe constrained details, right? So it will basically enhance the clarity on the ER diagram, right? Uh, and it is also observed that in few situations where the database is huge, I mean, the ER diagram itself is a huge, it is having more than 50 or 60 entities, something like that. There, this role of generalization and specialization is become critical. So that's what it is observed also, and it is said that particularly in the newer application of the database technology, such as a database for engineering design and manufacturing, which is using CAD/CAM, maybe in the telecommunication, maybe in the complex software system design and GIS system design, right? So there are various situations, various business requirements where we realize that there could be more, I mean, higher number of entities possible for the given data requirement. So we need to perform either specialization or generalization. That's possible simplistic case, right? So what is the typical definition, or what is the typical concept of specialization and how it is being implemented? So specialization, as we have taken, specialization is a process of refining a entity, simplifying an entity. So basically on the base entity, we observe that there are various data values which of one type, there are other database tuples which are of different type. So either you can split the entity into sub entities. So process of specialization is a process of creating the subclass, naturally based on some attributes. So whenever we are splitting our entity into sub entities and we are moving some attributes, some tuples or some data objects into one set of entity, and some are from the some are moving to the different type of different entity 2. So when we partition the data horizontally to move into two different entities, it is the attribute also which are moving to these entities also, right? So the primarily you can say that specialization is the process of simplifying a main entity, simplifying a base entity. Now there is another process which is we are referring as a generalization. So generalization is what? Because generalization is there to merge or to combine two similar entities from two different databases. So whenever we say we are combining two similar kind of entities, we are naturally deriving a superclass. So whatever entity we will derive by combining two entities, it will be a super entity, right? So let's see one by one. So first, let's see the specialization thing and how it is basically implemented, or how it could be affecting the basic ER diagram. Now you can see here in this diagram or in this figure, we have identified or we have placed the entity named employee, right? So we assume that we have created a database, ER diagram of ER database requirements, and in that ER diagram we have realized an entity as employee. Now in the employee entity, we could have attributes like first name, assistant, birth date, address, and typing speed, T grade, engineering type, pay scale. So basically what happens in the base end, so you can see the different attributes. So right now attributes are placed with entities like secretary, technician, engineer, but in the beginning, in the basic ER diagram, all these attributes which are rightly available in the diagram and placed on a different entity, in the beginning each and every attribute is placed on the base entity, right? That is the input for the specialization. So on the base entity or base diagram, all the attributes will be placed on the entity employee. Now when we realize that for some employee this typing speed is not applicable, there will be null values for these remaining employee. There are some employee who are basically employment type as a secretary. So if you place attribute called employment or designation, so in that attribute there are some employee who are of secretary type, and for them this attribute called typing speed is applicable. But for an employee who is having designation technician, this typing speed is not applicable, right? Similarly for engineering type, I mean for this third type of employee, engineer, engineering type is applicable, but for remaining two it's not applicable. And that's why we need to define this subclass, this is specialization. So we have performed the first type of specialization of employees in our organization, and we have defined three types of three entities for three different types of employees, and we have placed the relevant specific attributes with each entity or each sub entity. You can see for security it is typing speed, for technician it is T grade, for engineer it is engineering type, right? So this is one of the specialization which we could perform, and we have taken out, we have inherited these three attributes to these three respective entities, and these three attributes are initially placed on the employee. Now because we have performed specialization, they are moved into the respective entities, right? So the first specialization we have performed. Now if you see, there is another specialization which is performed for salaried and hourly employees. So these suppose in our organization we have 100 employees. So the first specialization what we perform, it is based on the type of their designation, a type of their job, and we have created three sub entities. So we could perform another specialization based on their salary or based on their nature of employment, right? So maybe out of 100 there are 60 employees who are working as a salaried employee, and remaining 60 will be working as an hourly employee, hourly paid employees, something like that, right? So this is how you can perform the second generalization or second specialization also on the employee entity, right? So with this simplistic definition understanding on the specialization, you can point out here for performing the specialization, you can see there is this term called D is placed. There is this term, the particular letter, which is D, is placed. Now D is indicating a specialization with disjoint values. It means it means there will be no common employee between secretary and technician, technician and engineer, engineer and secretary. So each and every sub entity is exclusive. There is no common individual employee is existing in the organization. That's the simplistic effect of placing D. If there is an employee who is working as secretary and technician, both designation, then you should place here as a O, overlapping, right? So overlapping means between these two pair of sub entities there is at least one individual employee who is working as a secretary and a technician, something like that, right? So this is the simplistic explanation. Now let's see what is the possible effect of possible placement of overlap into the second probably example. So there is this entity called parts. Now parts is a base entity. Initially this part entity will have all the attributes listed here. Now if we perform specialization of nature overlapping, so you can see in the specialization area this O is placed, right? And if you are using overlapping, it means while performing the specialization, we have observed that there are few parts who could be of both type, manufactured and purchased part. Now, in the manufactured part as a sub-entity, you can see these three attributes are placed, which are related to the manufactured part type. There is another sub-entity which is purchased part. So this is another sub-entity, and this sub-entity is having these two attributes, supplier name and list price. And these two attributes are applicable to only purchased part, right? Because these parts are purchased. Manufactured parts are not purchased, they are manufactured on the organization, within organization, right? So that's why we need to place the specific related attributes to the specific related sub-entities, right? And naturally, whenever we are defining this specialization as overlapping, it means there will be at least one part which will be of both type, manufactured and purchased. That's why we have said it is a overlapped specialization, right? So these are the two basic examples to understand that we could have a specialization. We could define a specialization on an entity by having two types, disjoint and overlap. And whenever we realize that, okay, there is this specialization performed, on that case, for each sub-entity, we need to place the relevant attribute to the specific sub-entity taken from the base entity, right? So that's the two instructions which are important to understand here, that whenever we see a base entity, you can always realize that, okay, this entity needs to be simplified. It needs to be further broken down into more than one entity. And whenever we are breaking entity into sub-entities, it is important to understand that this specialization will be of kind disjoint or overlapping. That's one first decision. Second decision, which attribute will be going to which sub-entity, right? So two important factors you need to always remember while performing specialization. Now, moving towards the second property, or let's take one example before going to the generalization part. Yeah, so you can see a specific scenario. Maybe it is related to a database called college management, something like that, college management, database management, something like that. So there you can see on the first level, the entity called person is defined, right? So we have created a college database. There we have understand that, okay, let's create an entity called person, which captures all the living individuals who can be listed as a person. Now, with this, if you see, the first level of specialization is the first level of specialization of the person entity is a overlapping. Now, overlapping between employee, alumni, and student, right? So employee is the person who is getting salary and he is working for the organization. Now, alumnus is a student or maybe faculty who has been completed his or her degree from the institute. Now, student is a third entity which indicates list of students who are currently enrolled into the institute, right? So why it is overlapping? Because there are some employees who are alumnus of the institute also, right? Like if I say I have completed my one of the degree from this same institute and I am also working as an employee in this institute, and so because of my existence in this database, this specialization between employee, alumnus, and student is overlapping, right? Because my presence, my data will be applicable in both cases, employee and alumnus, right? Similarly, there could be some students who are uh, who are applicable in alumnus as well as student both. So it could be like if one student has completed his BTech from the institute and again enrolled for the MTech, so he should be listed under both alumnus because he has graduated from the institute as well as he is now enrolled as a current student in the higher degree. So the existence of this student makes this classic generalization as a overlapping, right? So first level of specialization, employee, alumnus, and student is overlapping. Now, if we go down further into the employee entity, employee subentity, you can see we have further decomposed employee into staff, faculty, and student assistants. So student assistants are the student is basically the kind of a category of employee who are getting some salary for assisting a teacher, assisting a faculty to perform some evaluation, for conducting exams, primarily to help a faculty conduct the you know academic activities. So primarily what happens whenever we see these kind of entities which are having relation with more than two entities, like this student assistance is related to the employee entity and it is also related to the student sub entity, because uh, it is possible that a current student could be also assisting a faculty, right? Like our MTech student can assist a faculty to conduct the exams of BTech student, something like that. So that's why it is so that this student who is currently a PG student or maybe MTech student, he will get some kind of scholarship, some kind of financial assistance to to perform the duties like assistance to a faculty. So that's why he is kind of shared class, shared subclass, which is shared between employee and student, right? So now if you see, there is a specific specialization of student based on his degree. Now you can see here, we have placed a D, which is disjoint. It means all the students currently enrolled in the institute could be disjointly arranged in the two disjoint sets. One set could be graduate students, and second student could be undergraduate student, something like that. Right now, further, if you see into the student assistance uh, subclass, it could be further specialized into two broad classes. One is research assistant, other could be teaching assistant, right? So you can see how a particular entity could be simplified, how it provides a detailed placement of detailed set of possible values on the particular entity. So if you are not performing this specialization in this situation, you could see that how many attributes will be left as a null entity, null values in the person entity. So if you have not performed this specialization and you have simply added the values onto the person entity, person database table, there are various fields, there are various record values are available there, the null value has been introduced. And when you have performed this specialization, you have realized that instead of having one single person entity, we should have at least employee, alumnus, student, staff, faculty, student assistants, graduate student, undergraduate, research assistants, and teaching assistants as the entity. Right. So by performing a specialization, you can get the simplified view of the same base ER diagram, and you can remove the possibility of null values, redundant values on the database table. That's the simple purpose of it. Now, going forward, the next property is a generalization property, right? And this is a second scenario for which we need to perform this design of enhanced ER diagram. So generalization properties say whenever we have two similar entities, when I say two similar entity means these two entities will have similar kind of attributes. So whenever we have these two similar entities, then we have to combine them, we have to merge them, right? And once we when start thinking about merger, we need to think about first, in the first step is the what are the common, what are the similar attributes available, what are the common attributes between them are available, and you can take out all those common attributes to the higher entity, to the superclass, right? So let's see the basic example. It is like you will be having these two entities, like first entity is a car, second entity is a truck. So let's take these two entity as an input entity, and we wanted to perform generalization. So how we will be going to perform it? You can see in the bottom side, it says uh, for the two input entities, car and truck, we can perform a generalization upward, and see there could be one superclass or super entity which is called vehicle, right? And it will have the attributes common to both participating entity. So you can see in the super class or in the super entity, vehicle ID, price, license plate, which is common in both participating or in input entity, is moved. It is placed on the super entity, and whatever attributes are left, it is not considered for the upward inheritance, are still available or is still located on the still placed on these two participating entities. Like for car, it is the maximum speed and number of passengers, which is applicable only for cars, and that's why it is not moved to the parent entity or maybe the super entity. Similarly, for trucks, it is number of, I think it's road or nodes, and tonnage. These two attributes are not applicable for the car entity. It is only applicable exclusively for truck. That's why it is placed on the this right side entity. So this is how you can perform or you can achieve a generalization, right? So generalization it looks like it is a reciprocal process. It is opposite process to the specialization, and that's obvious also. Now let's see how you can take a specific instance. So this particular E diagram is taken from one of the reference book for the database, and it is for basically justifying, explaining that how a basic ER diagram could be converted into an enhanced ER diagram. So now the basic ER diagram will have entities like person, department, maybe section, and course, right? So once you see that these are the 3-4 base entity has been defined into the basic ER diagram. Now, where is the possibility of extension of the ER diagram into the more detailed or more simplified view? So now you can see the person entity is further specialized into faculty and student. And once you define these subclasses like faculty and student, right? You need to define, you need to mention the relationship with the other entities also. So maybe initially the person entity is directly in a relationship with department, but because we have performed specialization of person entity into faculty and student, you have to position the relationship of the faculty entity with department and all the other entities in the ER diagram. So this particular picture gives you the utmost idea about the possible enhanced ER diagram, right? So it is not only about simply extending the entity, it is also about maintaining or keep recording the relationship with other entity in the ER diagram. So whenever a question is given to you in the exams that you have to draw the basic ER diagram, and further you have to define or use the specialization, then you have, in the very first instance, you have to draw the ER diagram, obviously, and in the second moment you have to introduce the specialization on one or two entities, and you have to draw the relationship with these newly introduced entities with the existing or remaining entities. You should mention the relationship, their cardinality, and each everything. Then only you can say that this enhanced ER diagram has been completed, right? So that is it. And with this, I can say the database design uh, portion of your syllabus has been completed. And from this lecture onwards, we will be now